All right, in this video, we're going to look at how do you use function notation to represent a linear function. The previous video, we looked at determining and writing the domain and range of a graph. Here, we're going to use function notation. So in this case, a function is basically where I have an input, which we call the x value, and I put it into what a function. It's like, I think of it like a vending machine. You put in $1, you push a button, and it gives you something out, right? So I put in an x value, and it says a number doubled plus 5. And I get an output, a y value, or what we refer to as g of x. You might see a different letter here. The name of the function might be f of x. So we kind of input, a number doubled plus 5, output, or y value, which is g of x. All right, so over here we have g of x, and this is the function I wrote, a number doubled, so 2x plus 5 plus 5. So the name of the function is g. The input, or the x value, is going to tell us what value to use or plug in to this, which is the function. See what I underlined there? All right, g of x means, right here, g of x means the output or y value of the function. So this is like when you do an ordered pair, it's the y value. For example, if my x was -1, that's my input, I plug that in, I do g of -1. Over here, I do 2. My work would be 2 times -1 plus 5. So 2 times -1 is -2. -2 plus 5 is 3. So my output, or like what g of x actually is going to be 3. My ordered pair would be -1, 3. Now, if I continued this process on this chart and like made a graph, you would see that, say my x value was 0. I do g of 0. So I do 2 times 0 plus 5, which is 2 times 0 is 0, plus 5 is 5. My output is 5. My ordered pair then becomes 0, 5. And you can see on this graph, I already put -1, 3, and 0, 5 are already on this little graph that I've made. Now what I can do is, given some of these blanks, I can try to fill in the rest. So if I'm taking g of 1, that means my x value is 1, which means I'm going to do 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. So my output is 7, making my ordered pair 0, 7. So then I would go, or no, my ordered pair is not 0, 7. That is a mistake. 1, because I cannot have 2 of the same x coordinates in a function. So 1. So I go over 1 and up 7. 1, 2, 3, 4, 5, 6, 7. I can put a dot up, a point there. This one, I have the output of 9, so now I need to work backwards. So I would think, okay, 5, so kind of like 9 is going to equal 2 times the number plus 5. So I can almost set this up. 9 equals 2x plus 5. So then 9 minus 5 would be 4. So 4 would equal 2x. 2 times 2 is 4. So that means that x would have to be 2. And then I would do g of 2, and that would be 2 times 2 plus 5. 2 times 2 is 4, plus 5 is 9. That's what I was given. So my coordinate becomes 2, 9, or my ordered pair. I go over 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what you could do on this graph, if it's continuous, is you could actually connect all these dots, and this function, in theory, if I was drawing a perfectly straight line on an actual graph, it would go on forever in both things. I could continue this chart. So again, that's how you use function notation, which is this whole g of x thing, to represent a linear function.